Now that we know how to solve rational equations, we're ready for an application of rational equations. And a great application is found in the world of circuits. Now, just any kind of computer electronic circuit. Now this is a resistor. You can see it looks like kind of a cylinder. It's got colored bars on it. All right, that's a resistor, found in a lot of circuits. Okay, now here's another resistor, and I'm going to hold these two resistors together in the middle, like this. All right, and when I put them together like this, just at one end, when I only connect them together at one end, then they are said to be in series. All right, so these two resistors are in series. When we draw that on paper, this is what it looks like. We draw squiggly lines to be resistors. Okay, so I'm going to label them R1 and R2. And notice how I've only connected them in one point. All right? Well, it just so happens that the total amount of resistance, when you put two resistors in series, the total amount of resistance is the sum of the resistors. That's easy enough. So if I have, for example, a 3 ohm and a 5 ohm resistor in series, then the total amount of resistance is 8 ohms. It's 3 plus 5. Now the ohms is just how we measure resistance, just like we measure time in seconds or hours or distance in feet. We measure resistance in ohms. All right, but if I put the two resistors like this, you see now they're connected end to end. Each end is connected to the other resistor. That's said to be in parallel. Here's what that looks like. I put my two squiggly lines and I connect them together on each end. All right? This is R1, R2. Now, when I write an equation for the total resistance in this circuit, it looks like this. 1 over RT equals 1 over R1 plus 1 over R2. Now, I can't be careful. A lot of students want to just flip this equation and say, oh, well, that means RT equals R1 plus R2. No, you can't do that mathematically. When you flip both sides, when you take the reciprocal of both sides, it has to be the entire side, not the individual parts of the side. All right, so let's suppose this time, let's suppose that, let's be a little different here. Let's say I have a 10 ohm and a 6 ohm in parallel. They're connected end to end, okay? They're connected end to end, so they're in parallel. That means that to get the total resistance, I'm going to use this equation right here. So 1 over RT is equal to 1 over 10 plus 1 over 6. All right, so to solve this equation, I'm going to follow my equation solving rules for rational equations. So I'm going to multiply this entire equation by the least common multiple, or the least common denominator. Well, the least common multiple of 10 and 6 is 30. And so I just tack a t, an RT, onto it. So I multiply the entire equation by 30 RT. Well, when I multiply this term by 30 RT, the RT's cancel, and I just get 30. When I multiply 1 over 10 times 30 RT, the 10 cancels with the 30 and leaves me with 3. So I have 3 RT. And then when I multiply 1 over 6 times 30 RT, the 6 and the 30 cancel to give me 5. So I have 5 RT. So 30 equals 8 RT, and RT equals 30 over 8, but I can reduce that. 2 goes into 30 15 times, 2 goes into 8 4 times. So really, RT equals 15 over 4, or I probably want to make that a mixed number because it's a real problem. So 3 3/4 ohms. This is what RT is. Notice that when you put resistors in parallel, that the total resistance is actually going to be smaller than the smallest resistor. All right, well, let's do a combination where there's a combination of series and parallel elements. And I'm going to leave my equations and basic pictures up there. Well, let's do this equation, or this circuit. Let's say we have a resistor here, come over here, a resistor here, Okay, so I have 3 resistors. Let's say that this one is 10 ohms, this one is 5 ohms, and this one is 15 ohms. All right, well, how do I work with this? Well, when you look at my picture, look at these 2 resistors. It looks like, they look like this picture right here. They look like they're connected in series because they're only connected to each other in this one point. And nothing else is connected at that point. So they look like they're connected in series. Well, if they are, then I can add them to get the total. And I can replace these 2 resistors with one resistor that's equivalent to their total. So my picture can become this. Alright, where I have one resistor here that's my 15 ohms, and then the other 2 I've added together, gotten my total, which is 15, and it's right here. Okay, so now I have 2 15 ohm resistors, and they look like this picture right here. They are in parallel. So now I can use this equation to get the total of these 2. So 1 over RT equals 1 over 15 plus 1 over 15. All right, well, I'm going to go ahead and add these because they have common denominators. 1 over RT equals 2 over 15. Now, I can simply take the reciprocal of both sides here, and I have RT equals 15 over 2, which, like we said before, you want to make this a mixed number. So let's make it 7.5. So RT equals 7.5 ohms. Notice that my answer is smaller than either one of these. In fact, when your resistances are the same, then the resistance that you get total is half of that. Let's do one more. Okay. So let's say I have a circuit that looks like this. I come over. Let's say this time that's my 5. This is 10. This is 15. Okay. Now when you look at this picture, these two look like this picture right here. The 10 and the 15 are connected at both ends. So they must be in parallel. That means I can figure out how much resistance I have just right here using this equation. And then I can replace these 2 with one resistor that's the same amount. So let's do that. Let's figure out what just the total for these 2 is. 1 over RT equals 1 over 10 plus 1 over 15. All right, well, what's the least common denominator here? Well, the least common denominator is going to be 30. 30 RT. So I'll multiply each term by 30 RT. Well, the first term, the RT's cancel out, and I get 30. When I multiply the 1/10 times 30 RT, the 10 cancels, and I get 3. And when I multiply the 1/15 times the 30 RT, the 15 and the 30 cancel, and I get 2 RT. So I have 30 equals 3 RT plus 2 RT. You're multiplying this denominator by every term and canceling as you go. All right, so 30 equals, and I can combine these, 30 equals 5 RT, so RT equals 6. So RT equals 6 ohms. So really, this circuit can be drawn like this. All right, where here is my parallel combination that we decided was 6 ohms. So I'll put a 6 here. And here's my 5 right here. I simply erased this and put a resistor in its place, and it was 6. So now these 2, even though they don't look exactly like this picture, look, they are connected at just one point. They're not connected on both ends. They're only connected at one end, and nothing else is connected at that point. So these 2 must be in series. If they're in series, then I can add them. So the total resistance for my circuit is 5 plus 6, which is 11 ohms. And this is how you work with, can't hardly see that, can you? This is how you work with combinations of resistors, and it involves solving rational equations.